In an experiment, we took a simple pendulum, and for different lengths of the pendulum, we measured the periods. We're going to use this to calculate a value of g with a 95% confidence interval. So we start entering the values into the spreadsheet. We change the number of decimals shown, and we keep entering the values. Once we've entered the values, we select them and create a list of points. We pan and zoom so that these points are easily shown. We remove the labels, and then we go and change the axis labels so that the axes show the correct information. Now, we need to create a model function for the curve fitting. I always call this m of x for model, but you can call it whatever you want to. In this experiment, the model function is a constant times root x. Once the model function has been defined, we can fit the line to the data points using the fit list function command. Now, to produce the interval, we will do Jackknife resampling. We do this by removing one point at a time from the list. So first we remove point A, we look at the fit and record the value of the constant. Then we remove point B and do the same thing. We just make a note of which point we remove, and then we continue. So now we've removed point C, we record the value of the constant again. And we do this for all the points. So we've got 7 points, and therefore we end up with 7 different values of the constant. And on these we can do some statistics. Finally, we will add the value of the constant for when we have all the points as well. So that is 1.9945. We now calculate g from the values of these constants. Now, according to the theory, g should equal 4 pi squared over the square of the constant. And we calculate this for all the values of the constants. Now we do the statistics on the g values directly. We find the mean, the standard deviation, and if we can't count to 7, we can always calculate it. Now, the standard error in this Jackknife resampling method is defined as the square root times the root of the number of data points, and the size of the confidence interval is 1.96 times the standard deviation. From that we calculate the minimum and maximum values, and we can see that the established value 9.82 is indeed within these limits. We finish off by producing a label for the entire diagram, and we do it a little bit fancy with color and style and size. And then we'll do another one which will contain the actual value plus minus the error limit. In this advanced section of the insert text dialog, you can find special characters and values of objects. Jackknife resampling enables you to find confidence intervals for fitted parameters.